All right, welcome to the last talk of iOS Conf Singapore. I will say my stay here has been wonderful, and I'm absolutely loving my first time being here in Singapore. Some of you may have seen a talk with a very similar name, and I promise that this talk is not that, just repackaged with some different branding. I do, however, really encourage you to go watch my talk that I did about 5 months ago at NS Spain, because this time I'm trying something different where I'm taking one talk and building it off of another. So a lot of the stuff that I'm going to go over in this talk is going to be building off the stuff from my previous talk, but with some filler to catch you all up. So with this, again, to sort of mitigate that confusion, I really thought, well, there has to be a way I can give a catchy name to this to catch people up. So I thought, okay, I could just take the original talk and add some cool branding to it, and maybe that'll disambiguate it. And then I was like, that just feels kind of cheap. Maybe I can grab a little bit of inspiration from some community members and things like that. I thought even maybe I could try my own logo to try and really disambiguate it. And then I thought, okay, there's Too Fast, Too Furious. There's the 222 method. This is the sequel. I'm going to roll with that. And, I just felt all of those were terrible. I'm just going to stick with what I know and stick with synthesizers. So as introduced, my name is Adam. I'm at B3L on Twitter. I'm a software engineer at Netflix, and I really do spend a lot of time working on animations, gestures, interactions, and really anything related to music. But more on the prior, because that is what really makes iOS fun for me. That's what really makes programming fun for me. And so starting off, what is an interaction? Well, if you look at the dictionary, it's basically communication or direct involvement with someone or something. And applying that with something being responsive, well, what is a responsive interaction? Well, again, it's something that's reacting quickly and positively. So you slam the two together, and it's something that reacts to your touches. It does so in a quick or positive manner and has animations that effectively communicate where you're going or how you got there. Now, for the visual learners, you don't want your animations or your interactions to feel like this. This is a very poor experience. What you want them to really feel like is this, where they use it and they're like, wow, that's really awesome. And iOS has a lot of great interactions that you can work with. There's touches and taps, there's scrolling, drag and drop, Apple Pencil, even cursor support. These are all various methods of interaction and input that you can use in your applications. And some developers have taken this really to the next level. Reader 5, an RSS reader, has this amazing interaction where you can swipe through all the pages really, really quickly. It's not using the standard iOS UI navigation controller. It's way faster, and so the app actually feels alive while you're using it. At any point, you can drag back if you accidentally tap on the wrong item. As just previously talked about, the Dynamic Island, one of the best additions to iOS in terms of interaction because it just feels so good and natural to use. It expands, things morph into it and out of it via metaballs. It's fully interruptible at every part of the stack. It just feels great to use. And so in my previous talk, we ended up building this app that ended up feeling really, really good to use. It was called Time Machine. It basically let you look at wallpapers from previous versions of macOS. And over the summer, I had an intern work on this to adjust it for this talk. And this is the intern. His name is Juno. And he specializes in messing with me while I'm trying to get work done at home. But he worked really hard on this, so we're going to check out his additions. So first off, he added support for scrolling through lots and lots of different wallpapers, not just the 7 that were up there. Also the ability to edit them, similar to Darkroom, with an editor. And he added some new sheet presentation animations, just to make it feel a little bit better. Some architectural notes on that. He used a collection view with compositional layout. He used some cells as SwiftUI views via UI hosting controller. The photo editor is SwiftUI mounted via a UI hosting controller. And really, it's UIKit and SwiftUI working together. And let's check that out. As you can see, it's scrolling really, really smoothly. You try and tap on things, the items will dismiss. We have this slider that works about 50% of the time. All right, okay, so we've got some work to do. He's still brushing up on things. He did a pretty good job, but there's some things we can do to fix this up. So first, there's unresponsive touches. The sliders are also kind of hard to use. They're not really responsive. Scrolling is lagging all over the place. And the dismissal gestures just don't really seem to work all that much. I really think he was sleeping during my last talk. That's why we need to catch him up. So here's our list of to-do things. First, there's unresponsive touches. Then there's this aspect of unresponsive scrolling. And lastly, there's these unresponsive gestures. So let's get started. So unresponsive touches. Touch input doesn't have a cursor. Your tap targets, if they're too small, a finger won't be able to tap on them. You need to acknowledge that someone has interacted with whatever you have. If you don't, the person using your application is going to be super confused and is probably going to try and tap it multiple times, which leads to confusion and frustration and potentially even deleting your app because it just doesn't work. And for every possible element that you can have in your app that can be interacted with, it needs to have a way to acknowledge and communicate that the input is being received and is being interacted with. So again, with the initial version that he built, you can see that as we tap on these items, there's no indication of what's happening. This could be the app stalling, this could be waiting for a network request. It's just really confusing because you have no indication of what's going on. And this is honestly what happens a lot with static buttons and stock buttons that you use from SwiftUI. You'll notice that when you tap on a button, it'll change the opacity, but that's the only thing that happens. And when your thumb or your finger is bigger than the button itself, you can't actually see if you tapped on that button. This leads to a lack of communication. It leads to it feeling unresponsive and potentially frustrating. And what you can do to fix this is using scale and opacity to really highlight that, yes, your input was received. You did tap on this button. It's much clearer and much more useful for having at scale within your application. So with my previous talk, we actually went into a full implementation of this, so I'm not going to repeat it here, but if you're curious, you can look at that. So when we apply this logic to our grid, you can immediately see that now it actually feels responsive. The interactions and inputs are being received and confirmed. It responds to your input. It gives you confirmation that something is happening. And it even uses a nice little spring animation to spring back and give a little bit of life to your application. Another thing you'll notice in some apps nowadays is this aspect of toggles that just don't feel really that responsive, especially ones that wait for asynchronous callbacks. They sort of wait to change the actual toggle state from on or off until the actual network request has completed. That makes your app feel slow and unresponsive. What you really should do is change the toggle, and then if the network request or whatever asynchronous request fails, switch it back, because at least it feels like your app is reacting and confirming your input. Another thing you'll see all over the place in iOS is this aspect of sliders. But these sliders are not that great because often when you're changing things, your thumb is covering the point at where you actually lift off. So you never actually know if you're tapping on the slider until you try and drag it. And sometimes the target is so small, you'll just miss it entirely. And that's just really, really frustrating. However, there's other sliders now making their way into iOS that just feel way better. Control Center and all the video players have it. You can see that there's no thumb to grab. You can sort of drag anywhere, and it reacts immediately. It's a lot more relative to what you're doing and feels a lot more responsive as a result. They also use scale to indicate that when your finger goes down on it, it scales up to give you an indication that there's more things that you can do with it. And it turns out that these are actually really easy to recreate, even in SwiftUI. So here it is here, and I know that's kind of hard to read, so we'll zoom in a little bit. And so what we have here is the basic outline of this volume control. So starting at the top, we'll see that on changed and on ended of this drag gesture, we have the scale that's going to change. So it's going to scale up to indicate that your finger is down on it. And when you take your finger off, it's going to scale back down to make it look like it's not interactive anymore. We also have an animation applied there with a spring, so it has a little bit of life. It springs back down. And following forward, you'll see that as, again, our finger comes down, it scales up, and then finger goes back up, it scales back down. And this is all building off the top of a drag gesture recognizer. And why a drag gesture recognizer? Because we're also using the finger and how you're dragging on the actual slider itself to manipulate the contents of it. So in this case, we're basically checking like, okay, what is the starting percent when you interact with this? And we're saving that state because, again, it's relative. Then, as you drag, we're going to advance that percent based on how much you've translated your finger across the screen. In this case, we're using 180 because that's just a hard-coded value that I felt nice. Depending on your slider, you might want to make it the actual width of the slider. It could be really anything. And we're going to assign the percent to be whatever the starting point was, and then plus on top of that, the translation that you occurred. So that way it's always relative. You can always take your finger up and off the screen, back down, and readjust. It's not absolute anymore. And so once we put that all together and put it in, you can immediately see how much more responsive this feels in use. It acknowledges your input as soon as you put your finger down on it. Dragging anywhere on the slider can adjust it. You don't need to find a little tap target and try and tap that. It's just far faster and more reliable to use overall. And speaking of reliable and easier to use overall, the new contextual menus in iOS are fantastic. You should totally use them. This is Ivory by Tapbots, the Mastodon client. But you can see that as I'm tapping on the options, I can actually interact with the entire contextual menu with a single gesture. I put my finger down on the screen, I hold it there, and I can pick an item just by going up and down. The highlight state of them all changes, there's haptics, it feels like a great interactive gesture. So, takeaways. As soon as a touch begins on anything interactive, you should communicate as such so that whomever is using your application feels empowered that they're using that. If you're waiting for something asynchronous, do so without blocking input at all costs, because blocking input makes your app feel unresponsive. And you can really use color or scale or other lightweight animations to increase the perceived responsiveness of your interactions. So, we got that done. All right, now on to scrolling. So the scrolling was sort of hitching a bunch. And UI Scroll View is one of the best ways to show large planes of stuff on iOS. There's not really any other alternatives. And so responsive scrolling is synonymous with smooth scrolling, like no hitching. And if your scrolling isn't smooth or it hitches, it is considered unresponsive. It's not that great of an experience. So again, showing this here, as we're scrolling, it's sort of hanging up and pausing. It looks like it's lagging or it's just not responding to what we're doing with our thumb. And that just makes the app feel broken or the device slower than what it actually is. And I know everyone keeps saying this word hitch, and hitches are, like Apple has coined, this new term for saying that is a frame drop. That is your device lagging in your application. And again, on ProMotion devices running at 120 hertz, that can happen quite a bit in unoptimized code. You have 8 milliseconds to do all of your work and get that out of the way so the next frame can come on screen. Otherwise, your app is just going to pause and wait for the next frame to come up. And so what do you say? Well, what do you mean by expensive work? And there's two aspects you got to look at here. So every time iOS renders something to display, it has a commit, and that's committing a frame. It's saying, I'm giving you a frame to the graphics card to have that rendered on the screen. And again, you get 8 milliseconds to get all that done and get to the commit deadline. If you do something that takes longer than 8 milliseconds, whatever it takes after that is how much your screen is going to hitch up and pause. And so you might be saying, well, how can UI Scroll View hitch? Like, it's always running. And yeah, it is, but it's also using in-process animations. So CA DisplayLink, for example, committing frames to the GPU every single frame that it's being interacted with. And this animation can be doing anything, really. It could be adjusting layout subviews. It could be updating your content based on things coming in, prefetching cells. There's a lot of stuff that can happen there. And if you're not careful, expensive work can really hang that up. So let's look at how to eliminate some of these hitches here. So Instruments came out with this new hitches tool, and it is fantastic. Let's look at how this works. So when you run your app and you hit the record button in the top left corner, you're going to run your application and see it not really do anything in Instruments. But after you're done recording, it'll download all the data from your app running and then give you this screen here. And you'll see at the bottom we have this really severe hang here. And so what we can do is we can set the inspection range to highlight just that area of where the device was hanging up. And so if we click on the left, there's a little thing called a time profiler under our application here, and that will give us a call tree of everything that was happening during that hang or hitch. And in this case, you can see there's this method here ominously called really slow method. I don't know what's going on there. Let's check that out. And you can see here, it is spinning up 1,000 CI contexts for some reason, and then calling itself, almost as if this is some contrived example. I don't know why. But you know, I'm going to blame it on him. So we put that together. You can see now it's way smoother. We removed that call. There's a lot less stuttering. But you can see there's still these sort of micro hitches that are happening. And that's where we get to the aspect of responsive image loading. And so most times when you're loading images from the network, you do something like this, be it async await or Grand Central Dispatch. You'd throw something onto a background queue, get an image from somewhere, maybe a network request or on disk, and then eventually jump back to the main thread and assign that to an image view. However, most image formats nowadays are compressed, and because we have devices that are Retina on a lot higher resolution, these images are a lot bigger and actually can take a lot longer to dump into memory to be rendered. Those images that are compressed need to be decompressed, put into video RAM before they can be blipped to the screen. And anytime you assign an image to an image view, it does all of that on the main thread. On older devices before, in the past, we had smaller images. This is much less of an occurrence. But when you're updating scrolling at 120 hertz and you have lots of work to do, it will happen quite a bit. And so thankfully, there's actually tools that can help with this sort of thing. So iOS 16 brought this new, I think it was iOS 16 or maybe iOS 15, but it's this image prepare for display. And what it does is if you put it onto a background thread, it will unpack that image asynchronously. And then when it's ready, it'll say, hey, I'm ready, you can put me on the screen. And then when you assign that image to the image view, there will be no more hitching that happens. It's far smoother and far better. And you can also cache these for future use. Just don't cache them to disk because they're not designed for that. So, preparing images for the display makes them ready immediately. There's no decoding or unpacking on the main thread. And again, this may not seem like a big deal when you're dealing with 60 hertz, but 120 hertz on an iPad Pro, it makes a really, really big difference. So try it out. So, some more quick tips. Clear the main thread as much as possible. Using the hitches tool is actually really, really fun because it feels like a video game where you're trying to track down and eliminate all of the hitches that you can possibly have. Do any sort of text or layout asynchronously if you can. That is some of the most expensive stuff that happens all the time, especially when you're dealing with apps that have a lot of text in them. And also be really careful with CLA or shadows, and same with masking. Those can incur a lot of off-screen rendering, which can really slow down your frame time and have you miss the commit deadline. So, now we've got scrolling fixed. All right, now on to gestures. So unresponsive gestures. Now this is where things get a little bit tricky because there's two aspects of it. There's two aspects to gestures feeling somewhat unresponsive. First, there's the latency of the gesture. Is the code backing the gesture actually performant? And second, there's the perceived responsiveness. Does the gesture respond to my input as expected? And so just like with touches, gestures really need to be acknowledged and complemented. If they aren't performant, it will lead to dropped input. And if they behave in unexpected ways, it will just lead to confusion. It's not what it's expected for the gesture to do. And some gesture recognizers really are just better than others for perceived responsiveness. So let's look at that. First, there's gesture latency. So much like the display updates at 120 hertz on ProMotion displays, most devices now actually update their touch events at 120 hertz. And which means if you set up a gesture recognizer with some sort of callback, in this case did pan, it's possible for that to be called every 8 milliseconds if you're swiping really quickly, which means that all of your code in that gesture recognizer needs to be really fast as well, or it's going to hitch or drop input, and that just doesn't feel great. So here's some quick tips. So anytime you're doing a gesture recognizer, try to avoid creating or copying expensive objects. Those will deter your frame times and will slow things down. Also, do not change the view hierarchy unless you absolutely need to, especially if you're changing wherever the hierarchy is for the view that you're currently interacting with. It will actually cancel the gesture recognizer, drop the view from whatever you're doing, and then put it into a canceled state, which almost always is never what you want it to do. And if you're dragging around a view, try to use translation on the layers transform, which is far faster than shedding the frame. Position can also be done the same way, but position can incur additional layout passes. So we'll see here that in this case, we're setting the origin based on a pan gesture recognizer. And this is fine in practice, but as you'll see in a bit, you'll actually want to do the latter, where you're assigning either the translation or the position to that localized in itself. Because when you set the frame, The frame actually sets the position and bounds, but also sets the transform. It's incurring a lot more work that has to happen during that gesture recognizer. Could you imagine if touches move with event was called every single time you were laying out expensive paragraphs of text? That would just slow things down and feel really, really bad. So you really should use position or transform instead of frame if you want to have performant gestures. So the next part, again, is this perceived gesture responsiveness. And if you're using a gesture recognizer that doesn't map one-to-one with the input of your finger, it's perceived as unresponsive, be it it's lagging behind, it's not following your finger, it could be any of those. Your code may be extremely performant and considered responsive via the latency, but the perception of it feels bad. And those are the types of things we're going to try to avoid. So you'll see here, with this dismissal here, it's using a swipe gesture recognizer. And a swipe gesture recognizer is a discrete gesture recognizer. It's something that fires, and then you forget about it. You don't even get events after the swipe happens. It's just, did the swipe happen, yes or no, and that's it. And this interaction makes it feel frozen until your finger lifts off the screen. In the same way, if you drag really slowly, it won't actually swipe, which in both cases are actually effectively breaking what this is supposed to be doing. So in short, please don't use this API. Just stop using it. It's not worth it. This is what you can do with it instead. And instead of that, you can adopt something like UiPan Gesture Recognizer, which 9 times out of 10 is better in every single way. You get continuous gesture updates. You get events exactly as they happen, changed, moved, ended, all of those states. And it makes any interaction feel like it's connected to your input. It maps one-to-one. Good gestures make interactions feel much more responsive. And do you know what also uses UiPan Gesture Recognizer? UI Scroll View does. It's backed by it. It's not backed by UI Swipe Gesture Recognizer because it's giving you continuous updates of the gesture that's happening. After you drag and let go, a decay animation starts on the scroll view, which is handed off from the gesture. Again, maintaining that one-to-one connection. This directly connects the content that you're scrolling to your input, and as such, keeps things always responsive. You can interrupt it at any point, and this is what allows interactions to really feel fluid and responsive. So if you ever want to have your interactions feel that way, copy how UI Scroll View does it, and it's actually really simple. So I mentioned a decay animation, and a decay animation is a special type of animation that doesn't really have a destination of where it's going to. It's initially seeded with a velocity. So picture your finger dragging on the screen and then you let go. It's probably going at like 500 points per second. And so the animation starts with that 500 points per second. And then it decays and slows down over time. That's how a scroll view slows down and eventually stops. But again, there's this one-to-one handoff that happens from the gesture recognizer, you let go, and then a velocity is passed to an animation that continues at the exact same speed and eventually slows down, just like in real life with friction. So here's sort of what it looks like in code. This is obviously a very simplified version of how a scroll view works, but in practice, this is effectively the same sort of model that you can apply to all interactions that behave sort of like UI Scroll View. So starting here, we're going to grab the translation and the velocity of the gesture recognizer. We're then going to start iterating over the state of the pan gesture recognizer and going through each of the changes in state. So first, when we begin, we're going to, again, stop any decay animation that's happening. In this case, it's a UI scroll view animation, which we don't really have access to, but assume that it does exist. Then what we're going to do is we're going to cache the origin point. Now remember when I was talking about the relative invocation of sliders, you're storing the current origin point of the scroll view so you can manipulate that relatively. So then as we change, we're going to relatively move the origin of the bounds of the scroll view to scroll its contents. So we're going to set the origin on the X and the Y to be whatever the starting point is plus whatever the translation value is of the gesture recognizer. And then lastly, we're going to start the decay animation with the velocity of the gesture recognizer, so it hands off. And you'll notice here that there's this really interesting loop where we're starting a decay animation, and then when the gesture starts again, we're stopping that decay animation, saving the current state of where the view is, Then we're moving to the change state, and then we're moving to the ended state again. It's creating this cycle that you can always interrupt the content. Again, finger goes down, you interrupt it, you save the current position of the origin, you then mutate it, changing the origin again based on the translation, and then you start up a new animation. And this is a really, really important cycle. This is called the interruptible gesture input loop. And I know that's a lot of words, but in short, it means that anytime you can interrupt and start it again. This is what leads things to feel really responsive. You're going from a began state, you're going from a change state, and you're going from an ended state. But the important thing here is that the animations are never blocking. They can always be stopped, they can always be redirected. So really, build your interactions so that they support this loop. Ensure this loop doesn't do anything more than it needs to, because again, time is critical and performance is really important for this to feel responsive. And none of the animations happening should ever block this loop from re-entering and restarting. That's the most important part. And there are third-party animations libraries that can help with that, including the one that I was introed to. So Motion is a framework that I built specifically for building things like this. It's an animation I wrote for building gesturally driven user interfaces, animations, and interactions. And it does all of the animations in process, just like UI Scroll View. It allows for creating interruptible animations with springs and decays, and it really leads to making responsive interfaces. However, it is not a replacement for core animation. It is a tool to help you when you need these really, really responsive interactions. And the cool part is we can actually just rebuild UI Scroll View using Motion. Because again, I exposed this sort of decay animation up here that you can use that behaves the exact same way as a Scroll View does. So again, we'll initialize that. It's going to iterate over a CG point, which is going to update every frame. We're going to, again, save the translation and velocity values of the gesture recognizer, and then we're going to move to the interruptible event loop. So again, we're going to stop the decay animation where it is. It's basically going to freeze the scroll view where it is, and then we're going to save the origin starting point of where the scroll view is at. Then we're going to change the bounds origin x and y to be whatever it is, plus the translation. And then lastly, we will set the velocity on the decay animation of the current gesture recognizer. We will update its value to start from wherever the scroll view is at, and then we'll start it. And it's off to the races. Again, if you want to move to the begin state and put your finger down, it'll stop the decay animation, you can move it, and so on and so forth. And this loop is effectively what allows things to feel really, really responsive. Obviously, this example isn't complete. There is a complete example for if you really want to see how scroll views are implemented in the Motion example app, which does things like rubber banding at the edges and allows you to really just build your own scroll views so you can understand how all of this stuff works together. So check out Cool Scroll View if you're ever interested. So lastly, going back to the app, you'll notice that this photo editor, it still feels not quite as good as it can be. It's not really dropping frames or anything, but it just doesn't feel as responsive as everything else in the app, as the buttons we're tapping on as the sliders, and also these photo cells just sort of randomly dismiss for some reason. So we can look at making this better. So you'll notice when the sheet fully presents over screen, it's covering everything. It's a really long animation that happens. That is a lot heavier than what it needs to be. If we want to have an app that feels really responsive, we need to embrace having some more lightweight animations. And so we can split up the sheet and the photo being edited into separate animations. And so when we do that, it looks something like this. You'll see that the photo sort of flips up. It switches from a square to a large rectangle. The container for editing it actually comes up from the bottom of the screen, and it just feels a lot better overall. And when you put them side by side, you'll notice that one does feel a lot heavier. It feels like you're committing to a lot more. Whereas with the latter, it's a lot more lightweight, and you can sort of just edit it as you want to, or check it out and switch back. And both the editor and the photo move separately, so they should both accept their own gestural input. They're both moving independently, so we should be able to control them independently. So we can have the system where if you swipe down the photo, it'll actually dismiss the photo and the editor. And if you swipe down the editor, it'll dismiss the photo as well. They're tied together, but they don't need to move as one. They can be interacted with separately. So let's look at applying that interruptible gestural loop here to the same example. So again, it's too big on screen, so we're going to zoom in. So here is the gesture recognizer running again. We're going to save the velocity and translation. We're then going to move to checking, well, which of these objects was interacted with. Was it the photo or was it the editor? And we're going to save that state for the rest of the gesture recognizer. So if it's the photo, we're going to look to see, is it the hosting controller for the photo? Because that's what's tied to the gesture recognizer for the actual photo itself. If it's the editor view controller, in this case the sheet coming up from the bottom of the screen, then we'll set the drag type to being the editor. And then moving forward, we'll move to our actual event input loop. So starting at the top here, there's the began, and from that we're going to switch on whether or not which type of drag point is being done. So in this case, we're going to move to the change state and check that out. And so with the photo animator, we're going to update its current value to be whatever the gesture recognizer set its translation to. And we're also going to post the value change, which iterates and tells it to say, hey, act as if you're animating for one frame and apply that value to the photo. So if you move it around, it's going to move it around with your finger, but it's not going to run an animation. And we're going to do the same thing with the editor. But in this case, we don't really want the editor to swipe side to side, so we're only going to change the Y origin of the editor itself. And so just like we did before, we're going to update value change so it just iterates on each frame. Lastly, we're going to move down to the ended or canceled state. We don't really care if either happen because that's not really important. But what is important is determining which of these is the thing that is being dismissed? Which of the things is the one that is being interacted with? Because that is the one that's going to determine whether or not we should dismiss both of them. In the case of the photo, we're basically going to say, well, is it past the bottom of the screen or was it swiped away fast enough? Past the middle of the screen, because that makes the most sense. If you're swiping something away, down towards the end of the screen. However, with the sheet itself at the bottom of the screen, we want to make sure that at least half of it has been dismissed. We want to make sure that when you swipe down on it, if it's fast enough, or if you swipe slowly and it's past the bottom of its height, then it should be the one that's dismissed. And then lastly, we'll go and dismiss that. And when you put it all together, you'll see that we have this really nice system where you can interact with the photo, you can grab it, you can redirect it at any point. Same with the editor itself. You can drag up, you can throw it back down, you can do whatever you want. And the cool part is because all of these are interchangeable and iOS devices support multi-touch, you can interact with both. And as long as one of them is the one that's supposed to be dismissed, both of them will get dismissed because they're linked that way. And so putting it all together, the nice thing here is these view controllers being interacted with are just UI hosting controllers. They don't have to be all in SwiftUI. They don't have to be all in UIKit. They're being presented manually as child view controllers because we're taking control and saying, you do what you want in SwiftUI land, and UIKit land, we're going to do all the animations ourselves. And this is just really how they can actually interop and work really nicely together. We're building responsive views, putting them inside of UIKit view controllers, and then doing our own animations on top of them. So really, to answer this very controversial question, they work really nicely together. So that's pretty much it for all the things that we had to fix. It just feels a whole lot better. And I know about that flip, you're kind of like, whoa, that came out of nowhere. It's actually really, really simple. So what we have here is we have two hosting controllers. There's the front of the card and there's the back of the card. And you just put them on top of another. And then you set the transform of one of them to be the opposite of the other, or off by half pi, by pi. And so when you set it, you'll see here that it's literally just a variable that we're applying to. And as we change it, the layer of one view controller is just being changed to be the opposite of the other. So as it flips, one is shown and the other is not. And eventually, because they are not rendered on each side, which is a property of CA layer, they'll actually be hidden when they're rotated away from the display. And so again, we started with this gross, hitchy mess, and just really not a great experience, but we moved to something that was way more responsive, way more interactive, and way more fun to use as a whole. And putting it all together, walking through every area of an app and finding delays or hitches is one of the best ways to improve responsiveness. If something is hard to use, it's not responsive. It's not responding to your touches. That's not a great experience. So fixing responsiveness issues like this really aid in making your app feel more accessible. And speaking of accessibility, sometimes these animations are actually too much for people using your app, so you have to take them into account as well. So consider checking for is reduce motion enabled, and then switching to something like a crossfade animation or something. So to summarize, responsive touches should always be complemented and acknowledged at all costs. Responsive scrolling, just really iterate on the performance to make it feel as buttery as possible. This is the way that you make scroll views feel responsive. And responsive gestures, always make sure that the interactions are interruptible and expected, because both of those are really important for making things feel great. To increase responsiveness, really just focus on the delays. Any sort of delay or hitch in your app does harm its overall experience. Using instruments as hitches and Time Profiler can really help to survey and find frame drops and solutions to these problems. So really try shifting your interactions to being interruptible, because the overall experience will get a lot better. And if you're just using Swipe Gesture Recognizer, just stop. It's really bad, and I'm surprised it hasn't been deprecated from iOS yet. And lastly, really just focus on the details. A lot of this talk has probably seemed like we're picking over very small details just for the sake of doing it. But these details really do matter, because if you skip them and you don't worry about them, they eventually incur these small sort of UI paper cuts. And when you take all those together, it makes your app feel like a really buggy mess that's not fun to use. Really focusing on all the details when you can elevate your app from a good app to a really great app. And so with some closing thoughts, creating responsive and playful apps are a great craft to practice. They're the reason why we have so many apps that are so memorable. Building gestural interactions that reward interaction with positive reinforcement really does make your app feel best in class. It's why apples are some of the best. And there's really nothing wrong with embracing the act of building fun apps with delightful expression. And one last thing. Now, you may have noticed that I used this image on the cover for some reason when I was talking about interactions and gestures. And that's because synthesizers have some of the most responsive controls you can use on a musical instrument. They are so fun and satisfying to use. And the reason that is because all of the buttons, switches, controls all interact really closely with the sounds they produce. You get immediate positive feedback from what you're doing, and it encourages creativity and things to try out, new ideas. This synthesizer in particular is called the Jupiter 8, and it is so important because it, along with the Juno 106, are the reason why we have such popular music from the 80s. It is almost impossible to find a song from that era that did not use one of these synthesizers. Queen, ABBA, Michael Jackson, all of them were inspired by the tactility of how well these things felt, that people are still vying to get these things to this day. And if you apply that same model to your apps, you'll end up inciting people to want to use them more, to get inspired, to get creative ideas based on using the tools that you're making for them. It becomes something that can rely on for years to come, and I think that is why, iOS has some of the best interaction and animation frameworks in the world, and there's just really no reason not to use it to make some of the best experiences that you can. Thank you.